Imagine trying to drag a 50-ton block of solid volcanic rock across raw earth. The friction is immense. Every inch requires an agonizing amount of physical force. This compares that stone to a school bus. A loaded bus maxes out around 15 tons. This block is over 3 times that weight. Now, scale that problem up. An ancient society successfully moved thousands of these 50-ton blocks to build a massive settlement. Grasping the physical reality of that weight is critical, because modern engineers still cannot figure out how human beings actually moved them. The site is Nan Madol. It consists of 92 artificial islands built directly on a coral reef in Micronesia, roughly 3,000 kilometers from the nearest continent. The builders stacked those massive columns horizontally and vertically, interlocking them like Linton logs to construct walls that reach 8 meters into the air. These stones are hexagonal basalt columns. Basalt is dense volcanic rock, and it does not occur naturally on a coral reef. The closest source is on the main island, separated from the reef by the ocean. That means the ruling Saudalor dynasty had to extract roughly 750,000 tons of this rock and transport it across open water. Moving 750,000 tons of stone across the sea is a massive logistical anomaly. It breaks our accepted models for 13th century technology. Nan Madol was constructed between 1200 and 1500 CE. We have to limit our search for a solution to the tools available at that time. No cranes, no engines, no modern machinery. Historians look to standard pre-industrial methods. For the land journey, the primary hypothesis relies on wooden sledges, log rollers, and raw coordinated human muscle. For the ocean crossing, the working theory is that workers loaded these 50-ton columns onto traditional wooden outrigger canoes to navigate the gap between the main island and the reef. In 1995, a team from the University of Oregon set up an experimental archaeology project to test these exact theories in the field. Theories on paper are easy. The only way to know if ropes, logs, and human hands could actually overcome the massive friction of these stones is to try it. The initial small-scale test did produce results. By using log rollers and ropes, a team of dozens of workers successfully managed to inch a single basalt column forward. This chart establishes our baseline data point. It shows the exact number of workers and the hours required to move just one 50-ton unit based on the Oregon team's results. Watch what happens to the data when we multiply that effort by the 750,000 tons of rock sitting on the reef. The labor requirements explode, and the timeline stretches far beyond the 300-year window the city was built in. When you apply the experiment's math to the entire city, the required manpower and time wildly exceed the population and resources the Saudalor dynasty actually had. The physical math shuts down the standard scientific hypothesis. We are looking at a finished, towering city, and archaeology does not have a functional model for how it was constructed. The Pohnpeian people who live there today maintain their own oral tradition about the construction. According to their local accounts, the Saudalor rulers used magic to levitate the stones, flying them through the air from the quarry to the reef. Archaeologists dismiss floating rocks as impossible, yet those same researchers are entirely unable to offer a mechanically viable alternative that fits the physical evidence. The raw facts refuse to budge. The quarry is on the island, the reef is out in the ocean, and 750,000 tons of interlocking rock are stacked high above the water. We assume human history is a straight, upward line of progress, but sites like this suggest otherwise. The builders possessed a system of logistical engineering that worked perfectly, and that system is completely extinct. Nan Madol leaves us with a stark reality. We have forgotten the names of the people who built these monuments, and we have entirely lost the knowledge of how human beings were ever capable of doing it.